Hello students, in today's session of NCERT Chapter Thermal Properties of Matter, very basics on the topic of transfer of heat will be cleared through illustrations. In earlier session we have gone through on thermal expansion and thermometry, means different types of temperature scales, thermal expansion, alpha, beta, gamma, and also thermal principle of calorimetry, that is heat gained equal to heat loss, in which conversion of ice into steam, etc., which you can review on YouTube channel sethiswiftlearn. In today's session, we are going to discuss transfer of heat by conduction. One is Stefan's law, Wien's displacement law, Newton's law of cooling, or thermal resistance, Ohm's law in heat, and other number of topics which are going to be very useful for 11th standard, CBSE, states, NEET, JEE, and other entrance examinations. It is requested, please go through the session completely. Now let's start with the question and concept. Question is, three rods A, B, and C of same material and having the same cross section have been joined as shown in the figure. This is the figure. Each rod is of same length. The left and right ends are kept at 0 degree centigrade and this is at 90 degree centigrade. Respectively, temperature of the junction of these rods will be, four options are given to, one of the option is correct. Concept, applicable, and solution. Heat transfer by conduction. Heat transfer conduction time delta T is equal to dQ, delta Q equal to Ka, temperature difference divided by the length into delta T. T1 is greater than T2. K is the coefficient of thermal conductivity. Coefficient of thermal conductivity. Coefficient of thermal conductivity. Right? Now, Ohm's law in heat transfer. Ohm's law in heat transfer. That is rate of flow of heat, delta H equal to delta Q over delta T, that is equal to applied temperature difference divided by the thermal resistance. Means, if we take H, delta H equal to delta Q by delta T equal to T1 by T2 upon L upon K. This L upon K is R thermal. L upon K is thermal resistance. So, thermal resistance equal to L upon K. This is Ohm's law in heat. In series and parallel follow the same as in the electrical circuits. Resistance, equivalent resistance series is simply addition, and in parallel 1 over Rp equal to 1 over Rp, R1 plus 1 over R2. K equivalent means in series harmonic mean and K equivalent in parallel arithmetic mean. These will be discussed in subsequent topics, right? Now, let's start the solution. Now, the solution of the question is, let theta be the temperature of the junction. This is junction. Say this is point P, Q, R, O. Heat will flow from this higher to lower, like this. Right? This is theta. This temperature is theta. Right? According to question, RA equal to RB equal to RC as L, K and A are same of all the three rods, all the three rods, because material is same, so conductivity will be same. Its length is same, area of cross section is same. So as R equal to L upon K. Right? Now that this is H1, this is H2, and this is H2. H1 plus H2 will be equal to H. These two are coming, this is just like a electrical circuit. This current is coming, this current is coming, this current is coming. Now, according to Ohm's law, delta H equal to applied temperature difference R thermal, right? Then 90 minus 0, 90 minus theta upon R plus 90 minus theta upon R equal to theta minus 0 upon R. This RR goes 180 minus 2 theta equal to theta minus 0, right? So 3 theta comes out to be 180 degree. 180. Theta equal to 60 degree. Means, according to question, B option is correct. Option B is correct. Right? Next question. Question is, a spherical black body with a radius of 12 centimeter radiates 450 watt power at 500 Kelvin. If the radius are half and temperature is doubled, the power radiated watt will be. 4 options are given to you, one of the options is correct. Concept, applicable and solution. Stefan's law. Stefan's law states that total energy emitted per second by unit area of perfect black body is proportional to the fourth power of its absolute temperature, that is E proportional to sigma T4 equal to T4. Absolute temperature is power 4. This is known as universal constant, Stefan's constant, that is 5.6 7 10 to the minus 8 watt per meter square Kelvin 4, or power radiated. E is energy per unit time per unit area, means energy upon area, energy upon time, area से multiply कर दें, this will become power. This will become power. Power radiated by the object will be this one. Where E is the emissivity, its value lies between 0 and 1. Now, according to question, P1 over P2 equal to same body, cancel हो जाएगा, area pi R2 square R1 square sigma cancel हो जाएगा, T14 divide by pi R2 square T24. So we have to find this goes, P2 will be equal to R2 upon R1 whole square into T2 upon T1 की power 4. Substituting values. On substituting values you get radius is half. So radius half कर दी, R2 will be equal to 1 by 2, and temperature is doubled, so this will be 2 की power 4. This is given to you P1. P1 is 450 into 1 by 4 into 16. This comes out to be 4. On simplification, this comes out to be 1800 watt. So this will be the answer. Let's check. D is the correct option. D is the correct option. Right. Next question. Question is 3 dishes. Discs A, B, and C having ready 2 meter, 4 meter, 6 meter, respectively, are coated with carbon black on outer surface. The wavelengths corresponding to maximum intensity are 300 nanometer, 400 nanometer, 500 nanometer, respectively. The power radiated by them are QA, QB, and QC, respectively. We have to select which is maximum. QA is maximum, QB is maximum, QC is maximum. Which is maximum? Concept applicable and solution. One of the option is correct, right? Concept applicable are Stefan's law as well as Wien's displacement law. We have to combine these two laws. Then we'll find the answer. Wien's displacement law states that wavelength corresponding to which the energy emitted by a black body is maximum and is inversely proportional to absolute temperature. Lambda is inversely proportional to absolute temperature. Lambda m dot into T equal to B equal to constant. And the product of lambda m and absolute temperature is constant. That constant is known as a Wien's constant. Its value is 2.9 into 10 to the power minus 3 meter Kelvin. Second is Stefan's law. This is that total energy emitted per second by unit area of perfect black body is proportional to the fourth power of its absolute temperature. Constant proportional is Stefan's constant. Its value is 5.67 10 to the power minus 8 watt per meter square. In the given question, we have to find the power. Power means W by T. Energy upon time area cross multiply. From Stefan's law, we know power will be equal to EA sigma T4. This is this one. And for Stefan's law, we get lambda m T equal to B. This is equation 2. Now we have to correlate between lambda m and R. Relation, we have to develop the relation between P. So P is equal to E into pi R square sigma. T4 की जगह पुट कर सकते हैं B upon lambda m 4. Right? Means this is constant, this is constant, this is constant, this is gone. All will be consumed in the constant proportionality. R square by lambda m की power 4. Now, QA, PA is to PB is to PC. PA is to PB. इसमें Q ले रखा तो Q ले लीजिए हमेशा. Or you can say QA is to QB is to QC. R का क्या रेशो है? That is 246. 2 का स्क्वायर, 4 का स्क्वायर, 6 का स्क्वायर अपॉन. ऑन सिंप्लीफाई पावर 4 है, रेशो में 100 है, तो 100 कैसे लोगे? 3 की पावर 4 3 4 5, 3 की पावर 4 4 की पावर 4 5 की पावर 4, ये रेशो. इसको अगर सिंप्लीफाई करें वी विल गेट 0.05 is to 0.0625 625 and last one 0.0576. So this is maximum. QB is maximum. Let's see the answer. Let's see the answer. B option is correct. Option B is correct. ये न्यूमेरिकल वैल्यू पुट कर दिए, मेथड बता दिया, कैलकुलेशन आपके लिए छोड़ दिए, फाइनल आंसर मैंने यहां लिख दिया है. राइट. नेक्स्ट क्वेश्चन. Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE board, JEE main, JEE advanced, NEET, CUET, and other entrance examination. These concept clearing videos are very, very helpful and useful, which you can review on YouTube channel sethiswiftlearn. In addition to this, I would like to say that these papers, complete video sessions are available on sethiswiftlearn YouTube channel, which you can review on sethiswiftlearn. In addition to this, further, these papers, detailed solution with additional information available on website sethiswiftlearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल sethiswiftlearn सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the question. Question is, the ratio of specific heats of two spheres is 2:1, 2:3. Radius is 1:2, emissivity is 3:1, density is 1:1, and both are having the same density. They are kept at same temperature in atmosphere. Which sphere will cool at faster rate initially? Cooling by radiation is given by this formula. E is the emissivity, A is the area, 4 pi r square. Constant, Stefan's constant. M is the mass, C is the specific heat. C is the specific heat. This is constant initially, right? Constant. M is not given to you. To find M, you know density equal to mass upon volume. The M equal to density into 4/3 pi r cube. So minus dt by dt comes out to be E into 4 pi r square into sigma upon rho into 4/3 pi r cube into C, right? Into T4 minus T04. According to question, consume the quantities which are constant into constant of proportionality. 4 pi, so dq by dt is rate of cooling. Rate of cooling by 1. Rate of cooling will be proportional to heat constant proportional to E sigma upon R rho C, right? Therefore, rate of cooling by 1 equal to rate of cooling by 2 will be equal to emissivity E1 over E2, R2 over R1, rho 2 over rho 1, C2 over C1. Simplify E1 over E2. Specific heat 2:3. 2:3 means 3:2. Right? Density 1:1. radius is given to you 1:2, so 2:1, because this is, and emissivity 3:1, 3:1. Now this is goes, it comes out to be 9. The rate of cooling of 1 is 9 times rate of cooling of 2. Means cooling of sphere 2 will be faster. Rate of cooling of sphere 1, that is first sphere, faster. Right. Next question. Question is, a body cools in 10 minutes from 60 degrees centigrade to 40 degrees centigrade. What will its temperature after next 10 minutes? Temperature surrounding is 10 degrees centigrade. Concept applicable solution. Concept applicable Newton's law of cooling, which states that rate of cooling of a body is directly proportional to the temperature difference between the body and its surrounding, provided the temperature difference should be small. Means d theta by dt, ये time है, this is time, equal to theta minus theta naught. Theta naught is the surrounding temperature and theta is theta average, theta 1 plus theta 2 divided by 2 from 2. Therefore, according to question, 60 degrees centigrade to 40 degrees centigrade 10 minutes. Means theta average is 60 plus 40 divided by 2, that is 50. Then 40 minus theta in 10 minutes. Theta is to be find it out. Theta average will be equal to 40 minus theta upon 40 plus theta divided by 2. This is the average. Right? Now, theta naught is given to you 10 degrees centigrade. Now, 60 minus 40 divided by 10 upon 40 minus theta divided by 10 will be equal to constant proportionality cancel out 50 minus 10 upon 40 plus theta divided by 2 minus 10. On simplification, this goes 20 upon 40 minus theta will be equal to 40 upon 20 plus theta into 2. ये 2 पर चला जाएगा, ठीक है. This comes out to be 2, 2, 2, 4. 20 plus theta comes out to be 4, 40 minus theta, that is 160 minus 4 theta, 20 plus theta. 5 theta equal to 160 minus 20, that is 140. Theta comes out to be 140 divided by 5, that is 28 degrees centigrade. That is the answer. Means, what will be the temperature after 10 minutes? Temperature will be 28 degrees centigrade after 10 minutes. This is the answer. Right? Now, I would like to request, if you are new to my YouTube channel, sethiswiftlearn, Sethi, please like and subscribe to my channel and press bell icon to receive updates on concept clearing videos. Thank you.